Hello, Mr. Wakefield here. Moving on here to the next packet, the final worksheet packet, as a matter of fact. Our first section is section 3.7. We're going to start out in this section by revisiting something that we've seen before a little bit, and that is fraction equations. And we have a special version of that that will actually be a little bit easier than a lot of the fraction equations we saw before. We'll start out with that. But then at the bottom of the page here, we have our first visit with word problems, our first visit into the world of word problems. And so we're going to be seeing plenty more of them after this. This entire packet, for the most part, is dealing with word problems. As you know, we haven't seen any yet because I've put them all at the end of the class here in the final worksheet packet. And that will give you an opportunity to really start to kind of, as you go through the different worksheets in the packet, start to get used to word problems in general, because you'll be doing them on consecutive periods and consecutive videos, and I think that will help you. Okay, so because word problems, let's face it, those are challenging for a lot of students, and that's understandable. Okay, but I think this will help you. So let's go ahead and start out with these problems up here, these first four. Yes, these are fraction equations, as you can see. Equations because they have equal signs, and then of course they have fractions in the equation. But what makes all four of these equations special, and it will allow us to do a shortcut, which is nice, is the fact that there's a single fraction on each side of the equal sign. Nothing else, okay? Whereas back in the fraction equations section, which was 8.6 right here, we had fractions on each side of the equation usually, but we had other stuff too. Okay, we had a minus sign here. We had a +3 right here. We had a -5 right here. Okay, so it wasn't just a single fraction on each side. Okay, if you have just a single fraction on each side with nothing else, not even a minus sign, if you even have a minus sign that's outside of the fraction, that doesn't count, okay, for what we're going to talk about here. But if you have just a single fraction on each side, even if they're big fractions like these here, what you can do is a shortcut, and that is cross-multiplying, not cross-canceling, you guys. Don't cross-cancel. Okay, remember, you only cross-cancel when you are multiplying fractions. All right, these fractions aren't being multiplied, they're equal to each other. Totally different thing. So, but you can cross multiply. Let me show you why it works first of all, off to the side. You don't have to write this down. But we know that 1/2 and 3/6, those are equal to each other, aren't they? And I know that because if I reduce 3/6, it would be equal to 1/2. If I put that in lowest terms, it would be equal to 1/2. So I know that these are equal, right? It's not a coincidence, you guys, that if I cross multiply 2 times 3 and 1 times 6, okay, aren't those both equal to the same number? Okay, 2 times 3 and 1 times 6 are both going to be equal to 6. And so that means that what that basically is saying there is that if you've got two fractions that are equal to each other, their cross multipliers will then both be equal to each other as well. And that's what we're going to do here in order to solve these problems. But again, I can't say it enough. You only cross multiply when what? When you have a single fraction on each side and nothing else on each side. Okay, I want to just make sure you don't do it at the wrong time. Okay, now let's go ahead, since we do have a single fraction on each side, let's go ahead and actually do the cross multiplication. 10 times 54, what's that equal to? Your calculator will tell you that that is equal to 540. And then x times 12 is equal to 12x. And so just like up here where we found out that the two cross multipliers were equal to each other, it would make logical sense that the two cross multipliers here would also be equal to each other, and that's why I put that equal sign in between the two answers there. Okay, and what this does now is it creates a brand new equation where you can then solve it by getting x by itself. In fact, in this section anyway, when you do the cross multiplication, you will always end up with just a one variable linear equation, which we've solved many times before. Okay, that's the one that we originally learned in 3.1 up to 3.3. Okay, with these 4 different steps. All right, we'll do those same steps here. where in fact we all have a single constant term and a single variable term, one on each side, and so that's the step where we just need to divide out. Okay, that's all you got to do in that case. What is 540 divided by 12? Okay, that is equal to 45. Exactly. So we have 45 equal to x. I got x by itself. I'm done. That's all you got to do. Okay, let's keep going here. This next one here has a little bit of a different component to it. We do have a single fraction each side, so we can cross multiply. However, you got to remember that when you do the cross multiplying, you have to multiply the entire numerator times the entire denominator. And so I have to multiply 12 times this whole thing. And as we've talked about on a number of occasions before, when you multiply by something that has two terms in it, and this does have two terms because of the plus in between, you have to bracket it. So don't try to multiply it in your head. Actually write this down with the bracket. I don't need to bracket the 12 because that's just a single term. So I have a single term denominator being multiplied by a two-term numerator. So you got to put a bracket around the one that has more than one term to make sure you're multiplying by the whole thing. Remember we said that if you don't put that bracket right there, if you go like this is the wrong way to do it. If you write it like this right here, you guys, it'll look like you're just multiplying 12 times the first term here, 9w, and not the 8. Now you got to multiply by the entire numerator, so that bracket is necessary. Same thing here. If you've got 10 times this numerator, and this numerator also has two terms because of the minus, okay, you have to bracket the two terms there. Like that. Again, you don't have to bracket the 10 because that's just a single term. So if you're doing cross multiplying and one of the two things you're multiplying has more than one term, you got to make sure to bracket that thing. Okay, because we got to do the entire denominator times the entire numerator. All right. So if either one, whether it's the numerator or the denominator, if either one of them has more than one term, you got to put a bracket around that. This creates a linear equation again, and as you guys know, when we have a linear equation, we clear out the parentheses first by distributing. So I'm going to distribute the 12 here, and then I'm going to distribute the 10 on the other side of the equation. I then need to move the w terms to one side, and I need to move the two terms that don't have the w in it to the other. Okay, in other words, these two terms, okay, need to be brought together, and these two terms that don't have the variable in it need to be brought together. Okay, and so we do that by adding and subtracting. So I need to what? I need to, let me go ahead and rewrite the problem here since I ran out of room at the bottom of the problem there. So I'm going to add the 30w over with the 108w. And you're allowed to, at the same time, to move the two terms that don't have the variable in it to the opposite side. You could do that on the same line here. Okay, I'm sure we've done that before on some other problems. And we end up with what here? We end up with 138w with the 96 canceling. And then over here we end up with negative 46. Since I now have a single variable term and a single constant term, I am now ready to divide out like this. Okay. The w is now by itself. It's equal to this fraction. And as I've said before, if you end up with a fraction answered, then unless I tell you to make it into a decimal or a mixed number or something like that, otherwise you can just put the fraction in lowest terms. And believe it or not, this does reduce pretty far. If you divide both the top and the bottom here by 46, you get negative 1 over 3. Okay. Not expecting you to reduce it that quickly. Okay, you could reduce it a little bit at a time, but it eventually would be negative 1/3. And so that is problem B. As you can see here, problems 1 and 2 look very similar. Okay, not a coincidence. They are supposed to be similar. All right, I'd like you to try those right now before we get into our first set of word problems. Okay, so please try those. Hit the play button after that, and then we'll look at the answers and get into those word problems. Okay, number 1, again, because we have a single fraction on each side, that's the situation where you're allowed to cross multiply. So we want to do 30 times x, and we want to do 21 times 5. 21 times 5 is equal to 105, and so we end up with 30x on one side and 105 on the other. Remember, the two answers that you get when you cross multiply, put an equal sign in between them, and it creates a brand new equation when you do that, and then you just solve that equation, you'll be done. Speaking of solving, because we have a single variable term on one side and a single term without the variable on the other, that's the division step, since this is a linear equation. All right, and 105 divided by 30, if you put that in lowest terms, that would be equal to 7/2. Okay, so you're welcome to put that in lowest terms. All right, please do so when you get a fraction answer, unless it indicates some other way of putting the answer, like a decimal or something like that, as I mentioned earlier. Number 2. Very similar to problem B right above it there. We have numerators here that have more than one term, so when I cross multiply, you got to remember to put a bracket around those things that have more than one term in it, because you got to multiply the entire numerator times the entire denominator. So the ones, whether it's a numerator or a denominator, the ones that have more than one term, you got to bracket them in order to ensure that you're doing the entire numerator times the entire denominator. Okay, and so then we solve that equation. I distribute first, 6x plus 8, 5x minus 35. I then need to move over, and I did a little bit more slowly this time. I moved over the x's to the left, and then on the next step, I moved the 8 over with the negative 35, okay, because it has to be on the opposite side of where the x terms went. And you don't need to divide out like you normally would, because x is already by itself, as you can see there. Final answer, x equal to negative 43. Okay, so that is what you do when you have a fraction equation that just has a single fraction and nothing else on each side of the equal sign. Okay? All right, so now our first discussion about word problems. Okay, and one of the things that students struggle with word problems is the fact that it seems like each word problem is different, doesn't it, sometimes? Okay, so we need to be careful to go through each one and talk about how you should know what to do and how you will know what to do. Okay, in this particular section, there's 3 different types that are all going to have a similar result to them as far as how you set it up, okay? But there are 3 different types, so let's go over each one carefully here. But they will all have a similar setup, though, so that's nice. It says here, find the cost of 3 scarves. I'll explain that X thing here in just a minute. And you know what? Actually, let me pull out my clean sheet of paper that I was working with. Okay. That'll be easier. There we go. Okay, same problem though. Find the cost of 3 scarves if 2 scarves cost $29. Okay. In this section, one of the problems that we deal with is when they say something like this, where they say, if a certain amount of scarves cost this much, how much would it be if you change the number of items you buy? Another example could be something like, how many shirts, how much would it cost for 5 shirts if 2 shirts cost $15 or something like that? Okay, or find the cost of 6 bananas if 4 bananas cost $3, something like that. Okay, how do you handle that kind of problem? Well, before I deal with this specific problem, let me just let you know that when you do have one of those problems where where they ask for the cost of a certain amount of items, and then they give you another amount of items and give you the cost for that. Okay, that kind of problem. Let me first of all say that when they do give you a problem like that, you can assume that all of the items cost the same. Okay, and so just keep that in mind. All right. So like I said, again, if they said, hey, find the cost of 6 shirts, if 4 shirts cost $30 or something like that, you can assume in a problem like that each item, each shirt costs the same. Same thing here. Each scarf is going to cost the same. All right. So because of that, I want to show you an example. Speaking of shirts, okay, let's say that you're going, and you don't have to write down this next part here. We'll get back to the actual problem here in just a moment. But to help you understand this type of problem, though, let's say that you're going to the clothing store, your favorite clothing store, and right outside the store, you see this sign right here. Again, you don't have to write this down. Just follow me here on this scratch sheet of paper for just a moment. Okay? If all shirts cost $10, all right, and remember we were just talking about that, where in this type of problem you can assume that all the items are the same. So this is a good example of that. All right, so you're about ready to walk into this clothing store. It says all shirts cost $10. Watch this. Okay, speaking of fractions being equal to each other, isn't it true that if all shirts cost $10, then it would cost $10 for one shirt? But wouldn't it also cost $20 for 2 shirts, you guys? Because, 10 plus 10 is 20, and so $20 for 2 shirts, right? It would also be true that it would be $30 for 3, right? And you can keep on going with this. But here's my point. My point is that if you make a fraction out of these 3 different situations, like this, aren't those 3 fractions equal to each other? Isn't 10 over 1 the same thing as 20 over 2 if you reduce that fraction? And it's the same thing as 30 over 3 if you reduce that fraction? Okay? They're all equal to each other, aren't they? So that's what I'm trying to say here, is that when you have one of these problems where all the items cost the same, okay, then if you put the amount of items that you're purchasing on the bottom of the fraction, and then you put the total cost of all of those items, whether it's 1 shirt for 10 or 2 shirts for 20 or 3 shirts for 30, doesn't matter, okay, then you can make a fraction for this problem no matter how many shirts you buy, okay, or in this case, no matter how many scarves you buy, all right? So that's important because when you solve a word problem, you need to be able to set up an equation, all right? And when you have 2 things equal to each other, I know I have 3 things here, but we don't need. I just put that extra example there just to emphasize that it works for any fraction, no matter how many shirts you buy, okay? But that's what you need to do in a word problem, is set up an equation and solve it. And so these equal signs are very important here because we need equations. All right, equations have equal signs, right? So here's the thing. Anytime you're solving a word problem, and I'm going to jump into this problem now, and you're going to see how it relates to this one. So I'll keep this on the page, all right? Anytime you're trying to solve a word problem, you guys, what you need to do is you need to identify, first of all, what your thing is that you're trying to find. In other words, the thing that the question asks you for. What are they asking for? It says find the cost of 3 scarves. So they are telling you to find that cost, right? The cost of what? The cost of 3 scarves. And so what we're going to do is we're going to take that thing that they ask us to find, and we're going to attach a variable to it. You could pick any letter you want, okay? I usually pick X or Y. I'll pick X right here. So X is going to represent the cost of the 3 scarves. Okay, the variable represents the thing that you're trying to find, the thing that the problem asks you for. Okay, now once you identify what you're trying to find and you attach a variable to it, that's the first 2 steps. Identify what you're trying to find, attach a variable to it. Then here's the key part coming up. You then make an equation with that variable in it. Because if you can do that, then if you solve that equation, you'll now know what X is equal to. And then you'll be able to answer the question. One thing at a time, though. Let's set up the equation. Okay, as I said here, all right, if all the scarves cost the same amount, and we don't know how much they are, but that's okay, all right, because if all the scarves cost the same amount, then it's going to be the same type of situation as this is right here, where it says in the problem that $29 for 2 scarves, okay? Remember I said that if all the items cost the same amount, you can make a fraction no matter how many items you're buying, whether it's 1 item, 2 items, 3 items, whatever. So I can make a fraction for 2 scarves, and then I can make another fraction for the 3 scarves. All right? Remember, those are the 2 different scenarios. One scenario where you're buying 2 scarves for $29, and another scenario where you're asking yourself, what is the cost if I buy 3 now? Okay, that's basically what they're asking you. They're saying, hey, if you bought 2 for $29, how much would it cost if you bought 1 more for a total of 3 scarves? That's what it's asking. Well, so what do I put up here on the top of this fraction? Okay, well, here's how it works, you guys. The money has to go on top, and the amount of items has to go on the bottom. Okay, you could flip that if you want, as long as you flip the other one too. Okay, if you have dollars on top and scarves on the bottom here, you got to have dollars on top and scarves on the bottom over here. Okay, and so it has to be in the same order for each fraction. Okay, whether it's dollars and shirts in that order. See how it's dollars and shirts, dollars and shirts, dollars and shirts for all of them. This is dollars and scarves, dollars and scarves. Okay, it has to be in that same order for each fraction. So you got to have the dollar amount for the 3 scarves here. Remember, it's the total cost of all the items on the bottom of the fraction. That's what you put on top. Whatever the total cost is for the items on the bottom. So what's the total cost of all 3 scarves? Well, we don't know what that's equal to, but we have a variable for that, right? Okay, remember X represents the cost of 3 scarves. So what we do on the top, you guys, is we put X dollars. You could put a dollar sign there too, but usually you don't put a dollar sign next to X, so I just put the word dollars. The important thing is that it's the same thing here in both fractions. Dollars divided by scarves, dollars divided by scarves, all right? Both of them are dollars divided by scarves, and so you've got, it's set up correctly, all right? Those units of measurement, as we call them, the dollars and the scarves, they have to be the same and in the same order like I mentioned. All right, if they are, then you've set up your fraction correctly, okay, as far as the order that it's supposed to be in. All right, but make sure that the 29 goes with the 2 because it says that. It says that the 29 goes with the 2, all right, and then it says the X goes with the 3 because the X is the cost of the 3. So this is our fraction right here, you guys. Let's transfer that over to the actual paper here. Okay. So in one of these problems where all the items cost the same amount, you can make a fraction out of 2 different scenarios. One where you buy 2 items, one where you buy 3. Okay, and like I said before, if you're buying 6 items and 4 items, you can make a fraction where you have 6 items here and 4 items here, just so long as the total cost for the 6 items and 4 items goes above it. Okay, that equation would also be valid. All right, let's keep going here. I know you don't normally have words inside of equations here, and you don't need to keep them there. I just put the words here and also the dollar symbol, okay, the dollar sign, to make sure that the numbers were in the right place. Like I said, it's got to be in the correct order. Now that I know that, I'm just going to rewrite the equation without the words. You can just go right to the next step. You don't have to write this extra step here. All right, we know that this is a single fraction on each side, whether it has the words or not. So the next step is what, you guys? It's to cross multiply, right? Because you have a single fraction on each side. Remember, that's your next step after you set up your equation in a word problem, is to actually solve the equation. 2 times x is 2x. 29 times 3 is 87. And so what we need to do now is divide out, right? And what do we get here? Well, in this particular case, I know I say, hey, if you got a fraction, put it in the lowest terms. But in this case, I'd like you to make it into a decimal, even though it doesn't say that here. Remember, you guys, we don't ever talk with fractions when we're talking about money, right? Okay? And remember, it says cost. Cost is money. So if they ask you for the cost, make sure to put it in decimal form and not in fraction form, because we never talk about, something costs 87 halves dollars. Okay, that we never do that, right? So let's put this into our calculator. 87 divided by 2. If we divide it, all right, 87 divided by 2, it will give us the decimal answer. If it doesn't, let me know and I'll help you with your calculator. It might be in some different mode or something, but it should give you the decimal answer, and it would be 43.5. Okay, now we solved the equation, right? But in the typical word problem, most word problems, all right, you can't just stop right here. Now, some teachers will tell you you got to write a complete sentence as your answer, okay, when you do a word problem. I'm not expecting you to take it that far, okay, but I do need you to remember something very important, which happens on almost every word problem, and it's this, okay? If the problem has measurement in it, some sort of measurement in it, then your answer should as well. Okay, now you might be wondering, what exactly, Mr. Wakefield, do you mean by measurement? Okay, here's what I mean by measurement. Okay, anytime you have a number, and this is the first time this semester we've seen this, okay, and all the other problems we've done this semester, it was always just numbers and variables, okay, but notice this number right here, 3, it's not just 3, is it? It's now 3 scarves, okay? 29, it's not just 29, it's $29 now. All right? See, if I just say the number 29 to you, okay, that could be anything. That could be $29, it could be 29 cents, it could be 29, apples, okay? It could be 29 anything. But if you put the dollar sign next to it, it now becomes exact. You know exactly what I'm talking about when I say $29. $29 is not the same thing as 29 cents or 29 apples, right? So it becomes exact. You know exactly what I'm talking about when I say $29. And so dollars, therefore, is what we call a unit of measurement. Okay, it's a unit of measurement is something that makes a number exact when you attach that unit of measurement to the number. Okay, so 29 by itself could be a wide range of things, but $29, okay, we know exactly what that is. It's $29, okay? It's a little bit less than $30, right? We know what that is. All right. So, most word problems we do from here on out to the end of the class are going to have at least some sort of unit of measurement in it. Okay, scarves is also a unit of measurement because 3 by itself could be a lot of things. It could be 3 shirts, it could be 3 pairs of pants, okay, it could be 3 dresses, okay, in this case it's 3 scarves. So the scarves takes the number 3 and it makes it exact. It makes it so that you know exactly what we're talking about now. We're not talking about 3 shirts, right? We're talking about 3 scarves. So scarves and dollars, that's an example of measurement. What's the big point here? The point is that if your word problem has any sort of word in it that is a unit of measurement, something that makes numbers exact so that we know exactly what they are, then your answer should also have a unit of measurement in it. So then that begs the question, what would be the unit of measurement here that would go with this answer? Okay, here's how I know. If you go back to the equation we set up, it says that X is represented by dollars, doesn't it? Okay, it's measured in dollars. And so therefore this is going to be $43.5. You could use a dollar sign or you could use the word dollars. Okay, because we usually use 2 decimal places anytime you go to the store or the restaurant or whatever, you always have 2 decimal places like this, right? Okay, and as you know, let me remind you if you don't remember, if you have a decimal with only 1 decimal place, you can always put a 0 after that and it still means the same thing. You can always put a 0 onto the end of a decimal as long as you're on the right-hand side of the decimal point here, which we are when I put that 0. I'm on the right-hand side of the decimal point. Okay, putting in an extra 0 there does not change the answer, but it makes it look more like a dollar amount, doesn't it? Because we're used to having those 2 decimal places there. So because it says up here in the problem that X is measured in dollars, okay, therefore X must be something where you attach dollars to it in order to say what the unit of measurement is. Okay. Now you might be wondering, hey, wait a second. How do we know that this wasn't cents or something like that? How do we know it's not cents instead of dollars? Okay, here's how I know. Remember I said that the words have to be the same here. If you have dollars divided by scarves, this also has to be dollars divided by scarves. It can't be cents divided by scarves. That's how I knew that that was dollars. Okay? So you've got to usually you're gonna need a unit of measurement on your answer. All right. The only exception, and I don't even know if we're going to see any problems like this. Okay. I don't think we are, but if you see any unit of measurement in the problem, like I said, you've got to have a unit of measurement in your answer. Okay. Next problem here. Key word here in this next problem is ratio. Ratio means a fraction, okay? And again, that's fitting because we're talking about fractions being equal to each other in these problems on this worksheet. It says the ratio of salt to baking soda in a cookie recipe is 0.75 to 1. Okay, here's what they're basically telling you. They're telling you that if you make a fraction, all right, and when they say 0.75 to 1, you always put the first number on top and you always put the second number on the bottom. That's just how it's done. All right, but let's make sure to write down our words. Remember, the words are important when you do these problems here in this section. And so the 0.75 is the salt and the 1 is the baking soda. Now you might be wondering, wait a second, 0.75 what? Is it 0.75 ounces? Is it 0.75 tablespoons, teaspoons? What are they talking about? Well, when they use a ratio like this and they don't tell you how it's measured, whether it be teaspoons or tablespoons, it means that both the salt and the baking soda have to be the same. It could be anything. It could be teaspoons, it could be tablespoons, it could be ounces, it could be anything as long as they're both the same. They're both measured in the same way. So if this is teaspoons, this would have to be teaspoons. Okay, you don't need to know what it is. Just remember that they have to be the same when they talk like this, where they say ratio and then they don't tell you how it's measured. They just give you the two numbers. It means that they're both measured the same way. Okay, so they gave you this ratio, right? Now let's read the next sentence. It says, if a recipe calls for 1.5 teaspoons of salt, see, now they are using a measurement, okay, how much baking soda is in the cookie dough? Okay, notice here, and this is what we need to remember. If they give you a ratio of two different things, in this case, salt to baking soda, all right, then if they then mention in the next sentence, hey, we've got this much salt, now how much baking soda would also go in it with the salt? Okay, when they say something like that, where they give you a ratio of two different things, and then they mention that, hey, we've got this much salt, now how much baking soda do we need? That kind of situation, and you'll see that same kind of thing down here in this problem down here as well. It's in that situation that you also set up two fractions equal to each other, where the ratio is the first fraction. We already wrote that down. And then it's going to be equal to this right here. Now remember, the words have got to go in the same order. So the 1.5 teaspoons of salt, all right, that's going to go on top here because the salt went on top over here. Now, just to let you know, it's a lot easier to use decimals in an equation than it is to use mixed numbers. And so I'm going to convert this mixed number. You don't normally get mixed numbers, but since we did here, let's convert that to a decimal. How do we do that again? In case you don't remember this from a previous class, what you do is you take 1 divided by 2 in your calculator, and that would be equal to 0.5. Same thing as 0.5. Okay, and so you just attach that to the 1. Okay, so 1.5 is the same thing as 1.5. All right. Now, I need to mention one other thing here. They did mention that this isn't just 1.5, it's 1.5 what? It's 1.5 teaspoons of salt, right? So we need to write down all that information. That they would not mention teaspoons if that wasn't important. So let's get that in there. Now remember what I said over here. Okay, if the salt is on top and the baking soda is on the bottom, the salt and the baking soda have to be in the same order here. But I also mentioned that however you measure the top, that's how you measure the bottom. So if the top is measured in teaspoons, then the bottom has to as well. So then what do we put down here? Well, what's the question that they asked us in this problem? The question they asked us in this problem is, how much baking soda? That's the question. Just like in the last problem, we took the question, we attached an X to it. Same thing here. How much baking soda? That's going to be your X right there. All right, the amount of baking soda that goes with the 1.5 teaspoons. All right, remember it says if it's 1.5 teaspoons, then how much baking soda do you need? So the X is going to be the amount of baking soda that goes with the 1.5 teaspoons. All right, so down here, because this fraction has to be the same word on the top and bottom, like we said over here, it's got to be the same way of measuring it. Since this is teaspoons on the top, this must be the same thing, teaspoons on the bottom. Okay, because like I said, that's what you do when they give you a ratio up here in the first sentence and they don't tell you how it's measured. It means that they're going to be both measured the same way. By the way, before we continue any further, I want to make it clear here why I put the salt on top. Could I put the baking soda on top and the salt on the bottom with the numbers being flipped? You could have, but we don't traditionally do that because when they say salt to baking soda, key word there is the word to. When they say salt to baking soda, whatever goes before the word to, that's typically what goes on top. And whatever goes after the word to, that's what goes on the bottom. And that's how I knew that the salt was a 0.75, and that's how I knew the baking soda was the 1. It's because the 0.75 went before the word to, just like the salt did. So the salt and the 0.75 go together then. They both are before the word to. All right, and then whatever's after the word to, which would be baking soda, and it's also the number 1 that's after the word to as well. That means that the baking soda and the number 1 go together. And that's why I wrote that here. Okay, so remember, whatever goes before the word to, all right, that goes on top, and then whatever number goes before the word to, that would go with that same item, all right, on top. So salt and 0.75 both go on top. In the same way, baking soda and 1 will go on the bottom. So I just wanted to make sure you knew why I put it in this order here. And also why the 0.75 went with the salt. Okay, you know that now. Let me know if you have any questions, though. Okay, now, just like in the last problem, you don't have to do this step, but I'm just going to clean this up. You don't need the words in there when you actually solve the equation. We just put the words in there to make sure that it was in the right order. Salt over baking soda, salt over baking soda. Both of them are in the right order. Okay, now I can solve this equation. If I cross multiply, I get 0.75 times x is equal to 1.5 times 1, which is 1.5. And then I divide out to get the variable by itself. Okay, please don't be thrown off by the decimals there. The decimals are just like normal whole numbers. Okay, you got a single term here. All right, it's just like if you had 3x right here or 5x. All right, you would divide by the thing that's being multiplied by the x to get the x by itself. What do we get here? 1.5 divided by 0.75 in your calculator would be equal to, and let me move this up here. It would be equal to 2. But what did we say in the last problem, you guys? When we have a word problem, we usually have units of measurement. This is no exception. Unit of measurement in this problem is teaspoons. Because remember, 1.5 by itself could mean a wide range of things. It could mean tablespoons. It could be 1.5 ounces. It could be 1.5 pounds. All right. But the teaspoons makes it exact. We now know exactly how much salt they're talking about here. So teaspoons is a unit of measurement. Okay. And therefore, it must mean that the answer has a unit of measurement as well. It's not necessarily that same thing all the time, teaspoons. It depends on how many units of measurement you have in the problem. You just have to look at the variable and figure out which one, which unit of measurement it is. For X, okay, how is X measured? Well, X is the baking soda, right? Well, how is baking soda measured in this problem? Since X represents the baking soda, you need to look at how baking soda is measured, and we can see right here that baking soda is measured in teaspoons. So therefore, the answer is 2 teaspoons. You gotta say teaspoons. You can't just say 2. All right? Gotta say what the unit of measurement it is so we know exactly what 2 means. All right? All right, now, going on into the last 2 problems, I'm going to ask you to try these here. You can see here that number 4 is very similar to problem D, so I'll let you go ahead and try that in just a few minutes here. I want to talk about number 3, though, for just a moment. Couple things there. First of all, this problem is not like the first 2 word problems that we did. Okay, however, it has this key phrase right here. At the same rate. Rate, you guys, is a special kind of ratio, but it is a ratio. All right, it is a ratio where the words are different on the top and bottom. So this would be a rate right here. Okay, it's a ratio, in other words, a fraction where the words are different. Okay, so they're saying at the same rate. Doesn't same mean equal? And so what they're trying to do is they're trying to tell us that we have a rate in the first part of the problem, and then at that same rate, and then you make another rate down here. Okay? So what they're trying to tell you when they say this phrase in the middle of the problem is they're trying to tell you to make a rate or a fraction out of the first part of the problem. And then since they say it's going to be the same, they're trying to tell you to make a rate out of the second part of the problem too, and then you put an equal sign in between those 2 rates or those 2 fractions that you're going to create, okay, because it says the rates have to be the same. Okay, so let's see how that works here. So I won't give away too much here because I want you to do it yourself, but what they're basically saying is that you could make a fraction out of these 2 things here. It does not matter which one you put on top. Okay, as long as it's in the correct order with the words. So if you put pounds on top and square feet on the bottom, then you would put pounds on top and square feet on the bottom when you make the other fraction. Let me just make the first fraction for you. So 2 pounds, okay, LBS, remember, is the same thing as pounds. You can say the word pounds too, that's fine. And then 150 square feet underneath that. Again, you could put the pounds on the bottom, the square feet on the top. What's important is that when you do the other fraction, you guys, all right, it has to be pounds on top and square feet on the bottom because it has to be the same order as this one. Okay? Now, what is the variable? All word problems have variables. Isn't this the variable right here? Because it says how many, so that's the question they're asking you. How many what, you guys? How many pounds? Okay, so it's going to be X pounds then, because X is the representing this thing and it's measured in pounds. All right, and then it says that that's going to go with 500 square feet. All right, so I think you can kind of see. All right, if not, we'll talk. Of course, we'll talk about it after you hit the play button again. All right, but I think you can kind of see what's going on there. Please remember also, you guys, at the end of the problem, you're going to get some big crazy decimal right there. And the reason why I say that is because it says here to round to the nearest tenth. Anytime they ask you to round, they're telling you to take the fraction answer and to make it into a decimal. Okay, but don't ever round off unless you're told to. Okay, they're always expected to give an exact answer, not a rounded off answer unless you're told to. Here, though, it does tell you that you can round off. And so they're telling you to make it into a decimal, round it off to the nearest tenth, which is 1 decimal place, and we'll see how that answer comes out. And then, of course, we'll do number 4 as well. So hit the play button when you're done trying those 2 problems, and we'll see how those 2 problems come out. Okay, number 3. How did that other fraction come out there? We have 2 pounds over 150 square feet. All right. Remember, it has to be in the same order. So pounds over square feet means that this has to be pounds over square feet as well. Okay, feet to the second power, by the way, is the same thing as square feet. That's why I wrote it that way. You could actually say square feet instead. It means the same thing. But the point is that it's got to be in the same order. Now, the square feet is 500, so that's why I put 500 down here with that. But I put X with the pounds because, again, it says that X is this thing right here because that's the question. X is the question, as you know. That's how word problems work. All right. But it's saying how many pounds would be needed for 500 square feet. So that means that the question goes with the 500, which means that the X goes with the 500. And that's why they're in the same fraction there. Okay. So 2 and 150 go together. X and 150, or pardon me, X and 500 go together. And then it says at this same rate, which means that they are going to be two fractions that are equal to each other. Same means equal, as we said. Okay. Now we what? Now we... And I didn't do that step here where I cleaned up the words. Okay, I just jumped right to the cross multiplying, which is fine. I did 2 times 500 is 1,000. 150 times x is 150x. And then I solved that resulting equation by dividing out the 150. Okay, and when you put in your calculator, it should say 6.6666666, and then there's a bunch of sixes and then a 7 at the end. Since they want you to round it off to 1 decimal place, though, it rounds off to 6.7. All right? Because when it looks like this, you guys, and it keeps on going like that, here's the first decimal place, right? Since the next digit next to that first decimal place is 5 or bigger, that means that this number right here, which is in the 10th place, the first decimal place, that bumps up by 1. So it goes up to 6.7. Just reminding you about how to round off. Okay, if this number next to the 10th place, this number right here, if that number right there had been less than 5, then the 6 would have stayed the same. But because it's 5 or bigger, okay, then the 6 bumps up to 7. And so thus we have 6.7. Why is it 6.7 pounds? It's because the X is measured in pounds. And so we know, okay, that that's the unit of measurement that we have to attach to that answer. Again, do not just say 6.7. All right, there's units of measurement in this problem, and so we need to have units of measurement in the answer. Number four. In a cookie recipe, all right, once again, just like the problem D right above it, we have a cookie recipe. Then this works for any recipe, okay, where you have a ratio, all right, of 2 different things here. In this case, it's a ratio of flour to sugar, and then they give you a scenario where they tell you how many cups of flour there is, and then they say, hey, how many cups of sugar would you need in that same situation to pair up with that cups of flour? All right. And this is important if you cook stuff, all right? If they give you a ratio of 5-2 on the side of the box for the thing that you're cooking, all right, but you say to yourself, oh, I'm going to have a lot of people that I'm cooking for. I need to be cooking for a lot more. I'm going to need to use this many cups of flour, and you need to figure out how many cups of sugar go with that so that you don't ruin the whole recipe. All right. Obviously, the ratio of flour to sugar, if you mess that up, it could really change the taste of the thing that you're cooking, couldn't it? All right. So this is important to understand this. So if the ratio of flour to sugar is 5-2, what does this mean again? It means that since there's that key word there when we talk about ratio, the word 2, whatever goes before the word 2, all right, and whatever number goes before the word 2 over here, those two things pair up. So the flour is the 5, and since sugar goes after the word 2, and since the number 2 also goes after the word 2, then that means that sugar and the number 2 pair up. And so I wrote that down here. I have 5 for flour, 2 for sugar, and then like I mentioned in that problem up here, okay, since they don't mention how they're measuring the 5 and the 2 right here, we just say 5 flour and 2 sugar, but it means that these two things have to be measured with the same unit of measurement. So if this is teaspoons, that has to be teaspoons. If this up here was tablespoons, this has to be tablespoons. Let's see what happens here. Well, actually, in the next part of the problem, it mentions that it's measured with cups, doesn't it? Okay, so that means that when I make my next fraction here, it has to be cups divided by cups because it has to be the same, all right, in this situation, just like in the last problem. Okay, because they don't indicate how it's measured, so it's got to be the same. What is that other fraction going to be equal to? I'm about ready to show you here. Okay, well, it says here that the flour is 32 cups. All right, remember, flour has to go on top. So we have 32 cups on top. What goes underneath that fraction, though? You can see I made a fraction bar right here. What goes underneath that? Okay, well, it says how many cups of sugar? There's the question, right? How many cups? So that must be the variable. Okay, so how many cups of sugar? I wrote it down here off to the side. How many cups of sugar? That's your variable. I'm sorry, that came off the page. There it is. How many cups of sugar? That's your variable. All right, you don't have to write this down over here, although I do recommend it. All right, you could get partial credit if you like. For example, if you don't get the whole problem right, but you write down something like that, you could get a little bit more partial credit to actually tell me what the variable means, because then I'll know that you at least understand that part of the problem. But it's not mandatory. If you get the whole problem right, I'd still give you full credit as long as all the other work is there. Okay, but that's not a bad idea to do that. And it helps you follow along with the problem a little bit more easily too, because now you know exactly what X represents. All right, by writing that down. Anyway, because of the fact that it says that we have 32 cups of flour, and then it's saying in that same situation with the 32 cups, how many cups of sugar were needed, then that must mean that the X pairs up with the 32. And so that's why X and 32 are in the same fraction. Okay, just like the 1.5 and the X were in the same fraction up here, because it said for 1.5 teaspoons of salt, how much baking soda would you need? Okay, and we knew that that part was the X down there, how much baking soda, and so the 1.5 has to pair up with the X. Okay, and so here is our equation here. All right, again, flour divided by sugar, flour divided by sugar. Okay, it's got to be in that same order. All right. Believe me, the problem won't come out right if it's not in the right order. If you had said X over 32 over here, okay, while still saying 5 over 2 here, it will come out wrong. Okay, order is so important there. I then cross multiply. I get 5 times X is 5X. 2 times 32 is 64. There's my equation. I then divide by 5 to get the X by itself. All right. You could just reduce this fraction, or it's actually already reduced, 64/5. But let's face it, okay? And if you said 64/5 on an exam, all right, that would be fine unless I tell you to make it into a decimal, like I said, okay? When it comes to money, like dollars and cents, like I said before, definitely make that into a decimal. But otherwise, you can keep it as a fraction and put it in lowest terms if necessary, unless I tell you otherwise, okay? They're not talking about money here. They're not talking about dollars and cents. So you could say 64/5, but wouldn't it be better when you're talking about cups of sugar? If you go up to somebody and say, I need 64/5 cups of sugar, they're not really going to know what you're talking about, right? So in this particular instance, I am going to make it into a decimal, 12.8. And since I always tell you that if you have a fraction, to keep it in that form and put it in lowest terms, okay, and since this is a good time to make it into a decimal, I will go ahead, just so there's no confusion, all right, and I would do this on a test as well if I wanted you to make it into a decimal. I would say write the answer in decimal form. So if you get a fraction answer, in other words, you guys, and I don't tell you, as I know I've mentioned this already, but if you get a fraction answer and you put it in lowest terms, and I don't tell you to write it as in a different form, like a decimal form, for example, you can keep it in the lowest terms fraction form, okay? But this is a good time to make it into a decimal, so that's why I write that off to the side. And like I said, on a test question, I would do that as well, so that you're not sitting there wondering what form do I need to put it in. Okay, but if I don't say anything, okay, you can just keep it as a fraction and put it in lowest terms. And sometimes when you put a fraction in lowest terms, the fraction goes away and it just becomes like a whole number, okay? You know, like, for example, if you got like 6 over 3, if you put that in lowest terms, it just becomes equal to 2, right? And so, yeah, and then sometimes the fraction becomes just a whole number. That happens a lot, all right? But If I don't say otherwise, you can just, like I said, take the fraction and put it in lowest terms. That's fine. Okay. But here a decimal is good, so that's why we did that. Why did I say cups, though, you guys? I said cups because, like we can see here, X is measured in cups. Now, how did I know that X was measured in cups? Couple reasons. Number one, it says right there in the question that it says how many cups. So you know that they want it in cups. All right, they don't want it in teaspoons or tablespoons. The other reason we knew it was cups is because, remember, these two words have to be the same here, the way in which it's measured. These two words don't need to be the same, okay? They just need to be in the same order as these two words, all right? Same two words in the same order, but they don't need to be the same word on top and bottom. But the way in which it's measured, not the item itself, flour and sugar, but the way in which it's measured, which is in cups, that had to be the same. Just like we said up here, where it had to be teaspoons and teaspoons, okay? That's how it works with these ratios, like we said, all right? Has to be the same word there when it's written like this, with where the first sentence gives you the ratio and it doesn't give you the way in which it's measured, all right? So that's how I knew that it was cups. All right. So, and that is something that students struggle with sometimes, being able to put the right word into the answer when you have a word problem with measurement and everything. Okay. So let me know if you have any questions about being able to write out the answer correctly, or anything else here with the word problems, or with the cross multiplying and all that. Okay. But that concludes our first section here in the last packet. Plenty more word problems coming. The next section just has a little bit of the word problem concept. All right, we'll talk about that. That's the concept of variation. But then after that worksheet, the remaining worksheets definitely have a lot of word problems, okay? And so we'll go through them carefully, all right? We'll go through some basic fundamental concepts for word problems as well. That'll make it a little bit easier. So, but again, let me know if you have any questions along the way. All right, so take care, have a good day, and we'll see you back for that variation worksheet coming up in the next video.